To me, when an experiment fails, I just expect it at this point. It's just an opportunity to learn, and sometimes when an experiment fails, yes, it can be frustrating, but it can actually uncover some new cool things you didn't even expect. So, for example, a lot of discoveries actually have been made from failures. So failure is not always a bad thing in science. I work on batteries, solid-state electrolytes to be exact. So right now, our batteries, they last for about 10 hours. We have electric vehicles, but they don't last very long, and there's a big safety issue because let's say some of Tesla's cars actually blew up because of their batteries. Because batteries, when they overheat, they just... So what I'm working on is solid-state electrolyte, which hopefully will eliminate the explosion issue because they're a lot safer. Eventually, maybe in 10 or 20 years, all the batteries and everywhere, all lithium-ion batteries will be solid-state electrolytes. So safe and just last for a really long time. And also a cool application is they could be flexible. So you can actually sew the battery into a fabric. So let's say a soldier in a battlefield, instead of carrying really heavy battery packs that they have to carry, we can just sew them into their uniform. So something very cool.
I make little bitty biosensors that are essentially you can bring a lab to a patient's bedside as opposed to taking a sample and bringing it to a large instrument like this. So I fabricate 3-inch slides that are etched with nano slits about 1,000 times thinner than a human hair. I decorate those nano slits with chemicals that make it extremely selective, and they can target any molecule of interest. So like think of a cop on a busy highway that only pulls over the red convertibles and lets the other cars pass by. That's what I do with this sensor. So I can flow over a sample like blood, and we can stick certain proteins that we're testing for on the surface, and we can make a portable point-of-care biosensor. So say somebody has this disease, you want to find out early, right? You don't want to find out late when this tumor's huge and it's churning out huge amounts of this bad protein. You want to find when the person's healthy, when it's making very small amounts of it. So you want to detect things that are very, very low concentration. So you could think of it as like bringing the sensor to the patient's bedside as opposed to taking a sample, shipping it a week to some centralized laboratory, and it takes several weeks to get the results. Well, if you had a little bitty sensor and you could bring it with you, the results would be instantaneous. Imaging instruments are as big as this, right? They're huge. They're as big as I am. When we make these little slits on the nanoscale, that allows us to get rid of a bunch of things that are required for the instrument to work. So that huge surface plasma and resonance imaging instrument, it has to have refrigeration, it has to have fancy optics, it has to have a movable mirror, and all this stuff that we can't shrink down to something that fits in the palm of my hand. Well, all those things I mentioned we can get rid of if we start using the properties of the properties that change when we go to the nanoscale.
I just never really thought about that, how much things change when you go down to such a small scale. When you go down to nanoscale, things change vastly. Knowing how materials alter their behavior at those small scales and how you can utilize it, it can make everything smaller. I'm sure you guys remember big cell phones in the 90s. So now, because we're able to use smaller and smaller technology, we actually have a lot better cell phones, but they're a lot smaller. You can make things more efficient, smaller, lighter, and stuff like that. If you look at anything on nanoscale, everything just changes its properties. Let's say gold, it looks like, I'm sure people have seen gold. However, if you actually make gold nanoparticles, they will actually change color depending on the size. So whether they're 10 nanometers in diameter, they're 200 nanometers in diameter, they will actually change their color. That's just one of the examples why how things change on nanoscale. So what we're trying to do is see if we can apply those properties and how we can use the nanoscale properties to our advantage. So I think it's very important and has lots of potential, and it has lots of things we need to discover yet still. So.